As previously said, the range is the difference between the largest value and the smallest value. You calculate the range by subtracting the smallest value from the largest. The range helps the researcher identify how much of a difference there is between the data collected. It is useful to see how closely related the values are to determine if the data can be trusted. As the range can be heavily influenced by outliers, as the calculation is the largest number subtracting the smallest number. So if the researcher had an outlier of 34 and the rest of the data was 4, 3, 3, 2, 6, 5, then the range would be 32, which doesn't give a clear indication of how closely the values are related, as none of the values are close to the outlier. Also, the range doesn't show the shape of the data, as no other values are included apart from the lowest and the highest. There is no indication of what the other values are within the data and if they are closely related. So looking at the example of the thigh girth scores, the range is 29, and if I didn't have the data there, you wouldn't be able to see how related some of the data is. So the interquartile range, this is the range between the middle 50% of the data. This can potentially ignore the outliers that calculating the normal range has to include, showing maybe a true representation of how related the values are in a set of data. You calculate the interquartile range by finding the upper quartile and then finding the lower quartile, then subtracting the lower quartile from the upper quartile. But when calculating the interquartile range, you find the position of the value on the dataset. So the data is in rank order to find the position of the median. You do this by taking the number of values there are in the data. So in this example, so the standing vertical jump sample, there are 14 values. Next, you plus 1 to the number of values. Once you have done this, you then divide the value by 2. In this example, it would be 15 divided by 2. Then this gives you 7.5. So the position of the median is the 7.5th value. In this example, that would be 40.5, as the 7th value is 40 and the 8th value is 41. So halfway between is 40.5. Or you add the 7th and 8th value together, which equals 81. Then you divide that by 2, and it gives you 40.5. Next, to find the position of the lower quartile, you take the number of participants plus 1 and then divide by 4. So in my example, there are 14 participants, plus 1 to give 15 and then divide 15 by 4, which equals 3.75. So that is the position of the lower quartile. But I'm going to round the position value up to 4 so that I'm using whole numbers. Then the lower quartile is in the 4th position, so it would be 22 in this example. To then calculate the position of the upper quartile, you take the lower quartile's position and multiply it by 3. So in this example, it would be 3.75 multiplied by 3, which is 11.25. I'm going to round it down to get a whole number, so the upper quartile is in the 11th position, which would be 49. Once you have the upper and lower quartile, you take the upper quartile and subtract the lower quartile from it to give you the interquartile range, which in this example equals 49 take away 22, so the interquartile range would be 27. As I briefly explained in the previous slide about standard deviation, it signifies how spread out a set of data is from the mean, so the average. This is how you would calculate the standard deviation if you couldn't do it electronically. Firstly, you have your data with how many participants took part. In this example, the number of participants is 14. You leave that number of participants for later in the calculation. Next, you need to find the mean of the data set. So you add up all of the values and divide by how many values there are. So the mean in this example would be 72.29. Next, for each original score, you need to subtract the mean. It doesn't matter if you get negative values because we will cancel them out in the next step. Then you need to take the value that you have just created from having the original score and subtracting the mean. So you subtract the mean from each individual score. With that value, you need to square it. You need to then add all them values together, so the squared values that you get. Next, you need to subtract 1 from the number of participants, which equals 13. Then you need to take that number, so 13, and then divide the total of the squared values by 13, or the number of the participants take away 1. From that value, you need to square root it. So in this case, it is the square root of 111.91, which is 10.58. So 10.58 is the standard deviation of the resting heart rate for this data set. In this example, the standard deviation is quite high, therefore the data will be spread out. If it was represented on a graph, the graph would be wide. In this example above, both means are the same, however the standard deviation is different. This is because in the GYMNAST-1 column, the values are close to the mean, 53. The other values hardly differ from the mean, that's why the standard deviation is low. However, in the GYMNAST-2 column, the mean may be 53, so the same, but that doesn't mean that both sets of results are equal or will have the same standard deviation. In column 2, the standard deviation is high because the data is more spread out. It varies from the mean. Shown on the graph, this is how the two standard deviations can be represented. Hypothetically, the larger standard deviation, through 5.59, can be conveyed on the wider graph. This is because the values are more spread out from the mean, and as we know from the normal distribution curve, the mean is the value right down the centre of the graph, so the data is more spread out. Although the smallest standard deviation of 0.71 can hypothetically be seen on the narrower graph, this is due to the fact that the data values are more compact. They are in close proximity to the mean value. The range of the value doesn't deviate too far from the mean average.